Okay, so we went over functions very quickly in class today, so I want to just review it with you just in case you're having trouble with your homework. You guys have all seen problems like this: x times x squared minus 3x. And they would like you to solve this problem if x equals 2. You all know what to do there. What we're just going to do is put the 2 in for x. So this would become 2 times 2 squared minus 3 times 2. So that would be 2 times 4 minus 6, which would be negative 2. And 2 times negative 2 would be negative 4. So if you would solve that problem, then you would find that this equals negative 4. There's another way to write that, and it is called a function. They can also write it as the function of x equals the same thing that we have up here, x times x squared minus 3x. And instead of writing out if x equals 2, they would instead write find the function of x. So it would say find the function of x, which equals x times x squared minus 3x. Then find the function of 2. The notation of this type of function it can be confusing because it looks like you're saying f times 2 or f times x. But in this case, we're not. We're just using the f to notate that this is a function. And so all they're saying is that if you have this phrase right here, x times x squared minus 3x, and they ask you to find the function of 2, they just want you to put the 2 in for x and find the answer, which is what we did in our original problem up here. So basically, this problem and this problem are the same. It's just written in a different notation. It's called the functional notation. So you would just do the same thing that we would do here. You would put this 2 in for every place that there is an x, and you would again get negative 4. You also they can use any letter to notate a function. So it could look like this: if g of x equals x squared times 2x minus 1, and then they might say find g negative 2. Again, all they're asking you to do is to every place that there is an x over here, they're wanting you to put a negative 2 in instead, and then find out what that equals. So right here, we would put a negative 2 in for this x, then we would put a negative 2 in for that x, and then we would find the answer. Negative 2 squared is 4. 2 times negative 2 is negative 4 minus 1. So that becomes 4 times negative 5, which equals negative 20. So this is how you do functions. The other thing that we went over rather quickly in class was exponents. So I wanted to review that quickly with you as well. I have talked about how x to the 0th power equals 1. And I just wanted to briefly show you why that works. So if we have, let's back up a little bit and say we have the problem x to the 4th divided by x squared. We can see that x to the 4th is the same as x times x times x times x. And if we divide that by x squared, we can see that these x's cross off, and the only thing we have left is x squared. Now the interesting thing about this is when you divide the problem, when you have the bases that are the same, the bases are the x, and we have the exponents. In a division problem, you just have to subtract the exponents to get the answer. So 4 minus 2 is 2. That's why x to the 4th over x squared equals x squared. You could write it all out, but it's simpler to just subtract the exponents. So back to how x to the 0 equals 1. If we go ahead and follow that logic, x to the 4th over x to the 4th, this equals x times x times x times x all over x times x times x times x. They all cross off, leaving 1 over 1, which is 1. And if you remember, we can also subtract the exponents to get the answer. 4, take away 4 is 0. So that would be x to the 0. And that's how you can see that x to the 0 equals 1. So anything raised to the 0th power equals 1. Even something like 1048 to the 0th power would equal 1. The other thing I wanted to tell you about exponents was we are going to be talking about negative exponents. So you might see something like this, 3 to the negative 2 power. What does that equal? Well, when you come to a problem like this, let's take a look at, we're going to go back to how we're going to go back to our x's to figure this one out. Let's say we have x squared over x to the 4th. Again, writing that all out, it would be x times x all over x times x times x times x. These two x's would cross off, leaving a 1 on top. So the answer to this problem would be 1 over x squared. So if we remember, we also can solve this problem by subtracting the exponents because the bases are the same. 2, we always start with the top. We always start with the numerator. 2 take away 4 is negative 2. So the answer would be x to the negative 2. And we can see that that equals 1 over x squared. So a negative exponent simply means that you would transport the base to the denominator and take away the negative sign. We transfer the base to the denominator and take away this negative sign. So x to the negative 2nd power becomes 1 over x squared. Following that logic, 3 to the negative 2nd power would be 1 over 3 squared. We simply took the base, which was 3, and it was in the numerator. We put it in the denominator, and we changed this negative sign. We took it away and made it positive. So 3 to the negative 2nd power equals 1/9. We can also